All right, so here's the homework video for 6.1. Again, if you're having trouble with the homework, I highly recommend you take a look at some of the screencasts from Dr. Quatrin, you take a look at the book, you watch my video. The nice thing is we're going to continue in 6.2 to do all of this exact same work. All right, so number one, if we want to talk about critical values, we need our derivative, and we need our derivative set equal to 0. From there, I solve, and I know that I've got my critical value at x equals -2. A good rule of thumb thinking about a problem like number 2, when I've taken my derivative and I set it equal to 0, if you have your calculator on a quiz or a test, this probably wouldn't be factorable. If this is on the non-calculator part, it will be factorable. So I factor my polynomial, and I end up with two critical values at x equals -5/3 and x equals 1. 5 is a good example of something that wouldn't be factorable. So once you've taken your derivative, you set it equal to 0, we aren't going to be able to factor this by hand, so you can either use your polynomial solver or your graph to come up with the three zeros of 5x to the fourth plus 20x cubed minus 15x squared minus 70x minus 40. Continuing on our pattern, we know if we want critical values, we take our derivative, we set our derivative equal to 0, our value was factorable, and so I end up with critical values at 0 and plus or minus 4. Haven't mentioned it yet, but please make sure that you're using the x value. Don't just tell me the critical values are 0 and -4. Show me that x equals those values. Again, number 8 is a good example of a problem that if we were on the non-calculator part of the test, we would factor. If we were on the calculator part of the test, it probably wouldn't be factorable. But I take my derivative, I set my derivative equal to 0, I factored out a 15 to make my life easier. Since I ended up with x squared minus 6, I know that I get x equals plus or minus root 6. X squared minus 2 gets me x equals plus or minus root 2. Since the 15 did not have a variable, we do not have a critical value at 0. Now, these last problems ask for extreme points. I will never ask you for extreme points. I will only ask you either for the critical value or the extreme value. So don't expect anything on a quiz or a test to ask you for extreme points. But if we're trying to find extreme points, we're doing that same work from above. We're finding our derivative, we're setting it equal to 0, we're finding our critical values. But then we're actually taking the time to plug those critical values back into our function. So I've plugged in the fourth root of 16 over 5, which gets me -5.120. And then the negative fourth root of 16 over 5 gets me 29.12. Similar in 14, I find my derivative, I set it equal to 0 so that I can find my critical values. But since it wants the extreme value, I take the time to plug it in to my original function. Extreme values come from the original function. This is a question that we get asked a lot. What am I plugging into? If we're looking for the extreme value, we are plugging into the original function. Now, for the range, we're required to do just a little bit more work, and we're going to talk about this a lot more in 6.2. So I still find my derivative, I still set it equal to 0 so that I know what my critical value is. But because this is 1x squared, I should know that this is a parabola that opens upward, meaning my range is going to begin at that minimum and then go up forever. In order to find out that minimum, again, this is an extreme value, so I've substituted into the original to get my extreme value, and now I am able to give my range. Similar in 18, because this is a positive lead coefficient and a fourth degree polynomial, we know it's going to look most likely something like this, which means that we're going to end up with an absolute minimum somewhere. So once I have my critical value, which turns out only to be a single critical value, since if you set 6x squared plus 12 equal to 0, you get imaginary answers, I substitute into my original to get my extreme value. And then again, this was a minimum, so I know my range starts at that value and goes off towards infinity. All right, so that looks like that is the end of the homework. Let me just double check. That is the end of the homework. Again, the nice thing is we're going to spend a lot of time in 6.2 doing this exact same work, and then we're going to repeat this work in 6.4. So if you have questions about 6.1, definitely ask them when we're back in class, but we are going to spend a lot more time on this.